right, now that we know how to simplify square roots, let's go back to our problem. We were at 6 plus or minus square root of 24 divided by 2. And we want to simplify the square root of 24. It was not a perfect square number, so we are going to, off to the side, simplify square root of 24. And just like we did a second ago, we're going to look for a perfect square number that goes into it. Square root of 4 times square root of 6 makes square root of 24. And we chose that rather than square root of 2 times square root of 12 because the square root of 4 is a perfect square. The square root of 4 is 2. And so square root of 6 can't be simplified. So we have x equals 6 plus or minus. We're going to rewrite the square root of 24 as this simplified version. 2 square root of 6 all over 2. And once we have the square root simplified, we're going to look at the coefficient of the square root, the negative b term, and the denominator, and if they all share a like term, as they do in this case, we can divide both the numerator and the denominator by that like term. In this case, what that looks like is dividing by 2 over 2, because 6 can be divided by 2. Here are our 3 terms we're looking at to see if they have the same factor, and they all have a 2 in them. I can divide 6 divided by 2. 6 divided by 2 is 3. 2 square root of 6 is all one term. It's kind of like dividing 2x divided by 2. This square root part is what type of thing it is. This is how many we have. And 2x's divided by 2 is just 1x. 2 square roots of 6 divided by 2 are 1 square root of 6. And that's all divided by 2 divided by 2, which is 1. So we divided both the numerator and the denominator by 2. Notice we did not change the square root. 2 square roots of 6 divided by 2 is 1 square root of 6. Just like 2x divided by 2 is 1x, we never will change what type of square root it is. And that's why at the beginning we couldn't have divided by 2 over 2 here. This would have been bad because we can't divide the square root of 24 into 2. The square root, there's only 1 square root of 24, and the 2 cannot divide inside the square root. One last thing is that if it's divided by 1, dividing by 1 gives us back whatever the numerator was. So 3 plus the square root of x divided by 1 is still 3 plus the square root of x. I lost my minus somewhere. 3 plus or minus, 3 plus or minus. And this is a super strange number. It is like 5 point something. This is an irrational number. That's the plus 1. And the minus 1 is less than 1 point something. It's 0 point something. These are irrational numbers, but if you were to plug them into the original equation for x, these numbers will make the equation true. This could not have been solved by factoring. It could only have been solved using the quadratic formula or some other method that gets us irrational numbers. And I'd like to point out that it took a lot more work because this wasn't a perfect square. If we look back at our first example, when we did the square root of 64, we were able to evaluate square root of 64, and it was 8, and then we were able to continue on and end up just getting inexact answers. Whereas here, we cannot simplify, and so we end up with 2 solutions. One is x equals 3 plus the square root of 6, and one is x equals 3 minus the square root of 6. Those are the 2 solutions, and we're comfortable leaving them like that. These cannot be simplified. They are not like terms. And so that's our answer. So hopefully you feel good about being able to solve quadratic equations using the quadratic formula. If you still have any questions, feel free to ask your teacher, and I'm sure they would love to help you.